Hello and welcome to this video on how you can learn anything faster and smarter instead of slower and more dumber. In the video, we're going to talk about who we are as humans and what we can do with this pretty amazing brain that we have. We'll get into all the anatomy of it and the way the neurons work and everything like that soon. We're going to talk about when we do learn, what it means to learn, chemically speaking, when and where it happens inside the brain. We're going to talk about why it happens, why it works inside the brain for all mammals, ancient evolutionary reasons. So you use a little archaic human there with a spear. And then also we're going to talk about how you can purposefully induce neuroplasticity, which is a chemical state that allows your brain to change and adapt its neurons and neural pathways to make new and different connections so that you can quite literally learn. In fact, that's what learning is based on, new and adaptive neural pathways being formed. And my premise here is that you can purposefully induce a chemical state called neuroplasticity within your brain that makes it far easier for your brain to durably adapt to this new learned information. So in other words, you can learn anything faster and smarter using neuroplasticity. So let's jump into this. We'll start with a quick anatomy review, and then we're also going to talk very specifically about one use case or one instance where you might want to learn faster, which is if you had a stroke. So just at a very high level with respect to the anatomy, we'll all know that there's such a things as neurons and neural pathways, connected groups of neurons that do things. And I'm going to quickly skip to this little diagram here and talk about a stroke. We'll come back and cover each of these areas. But for right now, the stroke story. The stroke story goes like this. Say you had a bunch of neurons and neural pathways in your brain. Say there's 3 sets, and this is a gross oversimplification. But for now, we'll say that the first one here deals with speech, the second one deals with vision, and the third one deals with auditory, being able to hear. Again, not to scale. However, let's say you had a stroke. And it happened. And it happened, let's say, here. And it's bad. And those neurons are dead and they will never come back. Let's say it was even worse. It was here. All these neurons are dead and they're never coming back. You can't say your name. So you go to speech therapy. And you have appointments where you learn to talk again. How many, though? Maybe 6, maybe 16. The question is, can you get closer to 6 than 16? And the answer is yes, because what's happening in speech therapy as you're learning to talk again is your brain is learning to make a new detour pathway, where this neuron and these neurons used to be for sight and auditory respectively, but now with new neural connections, you can form a detour pathway where you can learn to essentially say your name again. Granted, you're going on a detour path, but it can happen. And it'll happen faster if you have your brain in this decidedly juicy learning state called neuroplasticity. And you can purposefully cause your brain to secrete those special chemicals that equal neuroplasticity. And I'll tell you how to do it. It's kind of like having a little reflex hammer where you can induce this chemical state. It lasts about 60 to 90 minutes. You would do it immediately before your speech therapy appointment. You would go into your speech therapy appointment. When you come out, there's a little extra thing you would do. Your brain would be marinated in those juices throughout the speech therapy appointment. Any neurons that fire during that 60 to 90 minute period, after you've purposefully induced this chemical state in your brain, you don't take a pill. I'm going to show you how to do this reflex type of thing. In fact, I'll show you right now. The reason I'll do that is because you'll better remember everything else that we're about to cover. So if you'd participate with me in this small exercise, I'll keep it very simple for now, and we'll do only an exercise that only involves your hands. That way, if you're sitting, you don't have to worry too much about doing anything that's a little bit more involved. Some of the exercises might look a little bit more silly if you're in an environment where you can't look too silly. So if you just join me and do the following, that would be great. You can just hold your hands anywhere. I'm sure they're on camera. And you just touch your thumb and your forefinger and count 1, the next finger 2, next finger 3, pinky finger 4, and then 4, 3, 2, 1 in reverse. And do that about 5 to 10 times. So 1, 2, 3, 4, 4, 3, 2, 1. I'm going to demonstrate it once more. 1, 2, 3, 4, 4, 3, 2, 1. Try to make sure that on both sides you hit in perfect unison. I'm going to give you just a second to do that. I'll do it too. Try to do it a little bit better and more perfectly each time, more precision. One more. Okay. Might not seem like much, but it is this. Your brain is now a little bit more chemically ready to remember what I'm about to tell you about. You may remember 9/11 if you're old enough, or maybe if you're more recent, you would remember the moment you heard about the COVID shutdown and that your life was going to be impacted. Your brain released a certain group of chemicals. There's 3 of them. We'll get into it. When they're swimming in the brain in the right proportions and ratios and with the right timing, anything that you learn, whatever neurons fire during that period of 60 to 90 minutes, say it was your speech therapy appointment, what happens is they get certain molecules attached to them, and then they're tagged for being stored off into long-term memory, whereas everything else is jettisoned. Neurons that don't have that tag, that molecular tag of acetylcholine is the name of the molecule. Again, we're going to get into that, but everything else is junk, and the important stuff gets stored off forever into long-term memory or closer to forever, and you can learn faster and deeper. You might have 6 appointments instead of 16. So let's jump into the particulars now of the brain. Just the quick review of the brain and sort of the 4 very loosely color-coded areas here. I mean, these are very loose with the green and the purple here. The prefrontal cortex, the blue area, kind of loosely is correlated in this drawing to who we are and what we do. This is the vaunted part of the brain that's in the front that does forward thinking. It does judgment. When you're inebriated, your prefrontal cortex is shut down. That's dumber. This hippocampus here, this red section, is when and where it happens in the brain. It starts in the hippocampus as the part of the brain that's most implicated in learning, initially forming memories and understandings of things that are newly acquired skills and learned ideas. And then it's eventually transferred off into this thing called the neocortex, which is, this prefrontal cortex is part of that, really. But again, this is not anatomically correct, but this is where we, I guess you could say, store off long-term memories. We'll call it that for now. Way more complicated than that. The amygdala and the autonomic brain are the functions of the brain that are happening without us thinking about them. They might be automatic functions like breathing or blood flow, but they also might be sort of automatic responses, like maybe if you saw a snake and you got scared, like this guy here. And then I'm going to teach you exactly how you trigger neuroplasticity. And there's things you can do. We're going to actually talk about them very specifically. It's similar to this thing we did with the hands there. Okay, moving right along. Who we are and what we do. We're Homo sapiens. We can think ahead and we plan to optimize our lives. We live, and living is learning. What is learning? As I said, it's a chemical transaction that can be optimized. Neuroplasticity we've already covered for stroke recovery as the example. What can you learn when your brain is in this state of neuroplasticity? It could be any information, skill, or idea, as referenced there. Also written there are the names of my associates. Most of those people I know personally and work with personally. Some are just very famous neuroscientists whose work is referenced and underpins everything I'm saying here. Everything I'm saying here is very old, very well settled neuroscience, probably decades old. Nothing is new or interesting except for my application of the well settled neuroscience. And the neuroscience is, of course, based on the anatomy of the brain. It is what it is. It happens how it happens, and how it happens is as follows. We've already covered the stroke example, but let's talk about this neuroplasticity. What is it when these chemicals are swimming in the brain? Soon we'll talk about how to release them, but for right now, what is happening when the chemicals are swimming in the brain? I use the term here. I'd like to credit the person who came up with this concept of the brain bubble bath, Dr. Wendy, and I do forget her last name. She's also a famous neuroscientist. I wish I could remember. I apologize to her. Neuroplasticity marinade, I could call it. I do call it. I also call it the magic memory mix. M3 with a little superscript. It's 3 chemicals. It's norepinephrine, dopamine, and acetylcholine. See, they each have their own little colors. When they mix together, that's M3. That's the magic memory mix. That's what was happening on 9/11. That's what happened when you heard that you weren't going back to college for COVID or whatever. Multipliers. You can do extra things to even further enhance this memory mix as it sits and marinates all your neurons up in your brain here. And then last of all, when neurons are tagged with that chemical that I had mentioned, which happens to be this acetylcholine. See, when the brain is swimming with all the chemicals, and let's say this middle set of neurons here is the one that actually is what your name, when you're in speech therapy, you keep saying your name, Steve Jarboe. That's my name. I don't know if I told you yet. Steve Jarboe, Steve Jarboe. And you say your name over and over again. And every time you say it, more acetylcholine molecules start molecularly attaching to that neural pathway, to that set of neurons. What that means is that you could see that even on a scan. When you go to sleep at night, see this last bullet says REM sleep equals long-term memory storage. When you go to sleep at night, your brain does a scan against every neuron in the brain when you enter REM sleep. And it says, which of you neurons has acetylcholine all over you? You're interesting. You that don't, you are not interesting. And you are condemned to be jettisoned from memory. You're irrelevant. You're all the people. You're 9/10. You're the day before I heard about COVID shutdown. You're not where I remember what I saw, who I was with, what I was wearing, what I heard. But on 9/11, I remember all of that because my brain on 9/11 in the evening found some information that had some neural pathways that had acetylcholine, and it took it from the hippocampus and it shot it off into long-term storage in the neocortex. That's that's what really happens in REM sleep. The neural pathways that have acetylcholine on them are identified as important, stored off into long-term memory, and the rest is jettisoned. And that's learning. And that's why you can make it happen faster. Because if you go into speech therapy appointment with your brain swimming with this magic memory mixture, you'll remember more how to say your name again. It just happens that way. I don't know how much faster exactly. I make no medical claims whatsoever. In fact, nothing that I'm really talking about here today is intended for medical application. This is all just for learning. This could be used to learn to play the guitar. It could be learned to use to weld better if you're a welding apprentice and you want to be part of building more ships. It could be for anything. I would also like to now cover the fact that up here in the brain, I just want to say that, again, the hippocampus and the magic memory mix, what that's called when you learn more quickly is one trial learning. It might be more than one time, but it would be less than more. And these chemicals that are swimming around all in the brain here, they're called neuromodulators. A lot of times on these diagrams, you'll see this little flower-looking thing. This means the good stuff, the stuff that is floating around loosely all across the brain. And that is distinct from something else I want to cover now. I want to jump into quickly the anatomy of the neuron and how that works. And specifically, you'll see here that each neuron is a cell that has certain parts. The body of the cell is called the stoma. This long axon or this long projecting arm is called the axon. Those things can go many feet. They can go from here to here, down in the body. They can be incredibly long. And these little guys at the end, these little fingers on either side of a cell, little tree branch looking things are called dendrites. That actually means little tree in Greek. And so each cell never touches the dendrites of the next cell, but rather there's something in between, and you'll have heard of the term synapse. So you have all these synapses or spaces in between, and the way that the cell communicates from one cell to the next is by sending little floating bubbles of chemicals across. I keep telling you this is a chemical thing. And those bubbles float across, and they are called neurotransmitters. See those little dots there? That's your neurotransmitters. They're there again and again. And they float from one cell to the next, and the extent to which they are immediately acted upon by the next cell, which would cause that next cell to send an electrical impulse down its length, down the axon, and trigger the next set of neurotransmitters to be released to the next cell, sending a message, making you say your name in speech therapy eventually. The way that you know how strong that pathway is how quickly the message sends. And the quickness with which that electrical message sends is called the action potential. And if you have a high action potential, that means that you can recall things fast. They're right there. You might have heard it called muscle memory. It's not. It's neural pathways that are well formed. The most famous saying in all of neuroscience is neurons that fire together, wire together. So if you keep on saying your name in speech therapy, Steve Jarboe, they're going to get really good at communicating. And the way that happens, I'm going to go ahead and diagram this out real quick. This magic memory mix down here, when it causes these neurons to get really good at learning, what that actually means is the following. I'll zoom in on this so you can see what's going on here. But what's going on is every time that one of these neurons wants to talk to the next one, it starts to send out its neurotransmitters. And those neurotransmitters float across, and they might have a couple different flavors, and they are floating. And what's happening is this cell can only produce as much neurotransmitters as it has dendrites. But when you do what I'm showing you, and you purposefully induce a state of neuroplasticity, and you cause neurons to fire together and cause the next neuron together to fire, which means they wire together, connect, and stay connected. What happens is you actually cause each of the neurons to grow more dendrites. So what's happening now is that these little chemical bubbles that are being sent across, all of a sudden, this first neuron is sending more. That's good. That increases the action potential, the efficacy of the neural pathway. In other words, your ability to even say your name. So you got a whole bunch more neurotransmitters coming. And even better still, this neuron here, being part of this neuroplasticity and this process that is actually called long-term potentiation. Long-term potentiation is when these neurons grow, they change, they can actually get, the dendrites can get longer, they release more chemicals, and there's more receptors on the opposite side of that synapse to catch the chemicals and say, I now need to take my action and execute my action potential. And thus goes the action potential along the neural pathway. Neural pathway. Long-term potentiation is the technical term, LTP, which is the growth of new dendrites and the ability to produce more neurotransmitting chemicals and the ability of the postsynaptic dendrites to receive the chemicals. The next thing that I want to cover is a little bit more about the autonomic brain and the amygdala, which is implicated in some, I pointed to this snake before, I think. This snake is an example of a person having a reaction to something that they experience, a stress reaction in this case. Stress is one way that I've referenced here, 9/11 and the COVID shutdown, or even a marriage proposal. That's not a bad kind of stress, but I call them major moments. Any major moment is one way to potentially induce neuroplasticity, but we can't cause a major moment when there's not naturally one. But we can do other things that cause the brain to secrete these chemicals. It's a natural induction. It can be simulated. These things that we can trick the brain into essentially thinking it's experiencing, even though it's obviously not, are ancient evolutionary triggers that are there to help us to stay alive and to survive. And if we know what they are and how to trigger them, we can just use them without actually having to experience these very maybe traumatic things. There's examples from archaic humans that I wrote here. One of them relates to something called the proprioceptive nervous system. It's the ability of you to know where your head is in relation to your body. In other words, if you were woken up in the middle of the night and you were hanging upside down like a bat, even in the pitch dark, even though you couldn't visually see that you were upside down, you would know. And that's because of your proprioceptive nervous system. It's got to do with the inner ear and other parts of your nervous system, which is the brain and all the projections of all the neurons throughout the body, the central and peripheral nervous system. Somehow your body can tell. And for that reason, when your body is in a position that it's not used to, like as in this diagram here, this is a little archaic human guy that has never seen a deep body of water. All their life they've drank out of a little creek, and now one time they come across a river, a big river, and they fall into it, and it's deep, and they're tumbling and they're upside down, and they're not used to that. This is not an experience they've had. Their brain in that moment says, this isn't good, this is terrible, this could cause us to die because we don't understand gravity. I have no idea what's going on as a brain. I better release the learning chemicals right now so that I can understand this new gravity so we don't get eaten by whatever prehistoric monsters would eat an archaic human that didn't understand gravity. So your brain takes a reaction. There's a way to trick your brain into doing that. I'm going to show you that one right now because as we get down, we're getting into the how to do it. but I think because I'm talking here about the proprioceptive trigger as compared to some of these other ones, I'm going to show you right now a way to trigger your brain to experience a little bit of confusion with its proprioceptive nervous system while you're also doing something else that uses this minute error correction mechanism to further trigger the neuroplasticity. I'll explain why this mechanism works in a minute evolutionarily, but right now I'm just going to show you how to initiate this proprioceptive pattern interrupt. Okay, it's taking your brain and giving it a little surprise. At the beginning of this video, I did a little silly thing where I said, instead of slower and more dumber. That was in effect a version of a pattern interrupt where you're expecting something and something else happens and it just causes you to be more suggestible. And we want the brain to be more suggestible. And the way you can make yourself more suggestible right now is by doing the following. Lean back gently and carefully with your head, I would say about that far back, if you can sort of see where I'm going there. Just as long as you can do it safely, you can sit. And then you can go back to that position in a second. Take both of your fingers like this, turn them like that so that when you put your hands straight down at your side, your pointer fingers are out, put your head back and successively touch your nose with just the very tip, I mean only the tip of your finger of each hand successively, bringing each hand all the way down before you bring the next one up. And you just try to be as precise with that tip touch as you can, just barely the tip. And you do that maybe 10, 15 times, be safe, be careful. And then you have done something to your proprioceptive nervous system, made it confused by holding your head in a very weird position that we don't usually do. And at the same time, you've also engaged in something called minute error correction, the same thing we were doing here. 1, 2, 3, 4, 4, 3, 2, 1. You could also do something like this. 1, 2, 3, 4, 5, 5, 4, 3, 2. See? You try to get it as good as you can. And in the process of making minor corrections, your brain is saying, I better release those chemicals. Here's an example from archaic history of ours. Why? Clearly, if you come across a snake, it's very akin to that major moment, that 9/11. That thing could kill me. I see it lives over in that hole over there. I'm staying away from that hole for the rest of my life. I'll never go near the snake hole again. I'm going to remember that snake hole. I'm not going to confuse it with all the other holes. I saw that thing and it was big. Look, it's almost bigger than the little guy. So what I want to say about this, the minute error correction, and the reason that things like this can have an effect on the chemicals inside our brain, why? It's because of the following. Let's say you were this Homo erectus and you're in a hunting band, and you and the hunters go out and throw spears at big scary animals. And you can't miss, because if you do, they might spear you with something, or the other hunters might spear you because you keep missing and screwing up the whole hunt and everybody's going to starve. So you can't miss. So you keep missing and you keep getting the sideways looks from your hunter crew. You want to practice to make sure that you don't keep missing. So you take your spear and you throw it at a tree, and you throw it 100 times at that tree. Every time you're trying to throw it just a little bit more correctly, a little bit more precisely, just like what we're doing here, a little bit better every time, a little bit better. And the brain says to itself, this is important. I don't want the guys to eat me. I don't want to be the one that screwed up the hunt. I'm going to get this right, or else I better get this right. And the brain says, release the learning chemicals, release the magic memory mixture. When you get that throw right and it sticks in the tree and the spear is in there, you want to remember exactly how you released it, where was your hand, how far. That's why this works, this minute error correction. It only works if it's something you care about, or you're getting ready for something you care about, like speech therapy appointment. So if you're in the waiting room and you do this in the waiting room and you care about the outcome that you're about to experience, you're in good shape. When the brain is inebriated, asleep, or dehydrated, those are not helpful for learning. And so I'm going to start to now move straight down into this section here about how to do it. And this is where we're going to talk about some of the baseline stuff, like if you're going to speech therapy appointment, to continue the example we're using, don't show up half asleep. You don't learn when you're asleep. If you're half asleep, you maybe half learn, but that's not good. Obviously, as we talked about, you can't learn anything if the prefrontal cortex is shut down. So inebriated or in any way impaired there isn't good for learning. And then finally, dehydrated also. It's just the whole chemical situation up here and all this, everything doesn't work well when dehydrated. So give yourself those benefits, but then do this other stuff I'm showing you before an important learning bout, immediately preceding a learning bout, which would be defined as a learning experience of about 60 to 90 minutes, usually longer than that, is the chemicals don't even stay in the same volumes. You'll never release them in the 9/11 volumes, but if you trigger them, you might release them in 30%, and you might get half as much, maybe. I'm going to teach you quickly these tools, techniques, and technologies. There's a lot more to say about this, and we can get into that in more detail another time. But very briefly, some of the basic overarching things that it's good to understand in your tool set is modern neuroscience literature. Like I said, Dr. Zach, my business partner, Dr. McCullough, my other partner, my good, one of my early mentors who taught me a lot about long-term potentiation is Dr. George Everly. Dr. Paul Pangaro is a genius. That's he's actually the leading authority on the science of cybernetics, which deals with recursive learning loops. And heavily, this might look to you like an AI diagram or even like part of a neural network with its back propagated learning loop. But what it is saying here, the way I use it, and the way I've always understood this, and this has been really a huge part of my work, is when we do learn this new pathway, we reinforce it. It's the same concept. This is neurons that fire together, wired together. Recursive learning in the field of cybernetics. Techniques. I've just covered the proprioceptive pattern interrupt. There's a bunch of different ways to do this stuff that I've been working on, because eventually you need to replace it with something new, because if you get used to it, now you're used to it. So if you're a Navy SEAL and you jump out of an airplane and your pitch, yaw, and roll, which are the 3 dimensions of your proprioceptive experience, are all over the place, for a normal person, that would cause a massive release of the 9. That would be comparable to the matter of chemicals that you had in your brain. When you hit the ground, you should study. You should do your speech therapy appointment as soon as you've done the skydiving. But if you're a Navy SEAL and you do that, it's old hat to you and it's just not a big deal, then it's not a big deal to your brain, and it won't trigger the release in the same way. You'll have to come up with something else. And that's what I'm interested in, is these techniques. So we got minute error correction, as demonstrated. Combinations, things like when you're leaning back and doing the error correction, and then others. And there's a whole bunch of others that I'm interested in. Technologies is also what I'm interested in. And my business partner, Dr. Paul Zach, is the leading authority on all measurable neuroscience. He's the most cited neuroscientist, in the top 1% of cited neuroscientists by his peers, because he is really legitimately an absolute authority on neuroscience technology and the measurement of the signals in the body through the cranial nerve, which extends all over, through wearable devices. He has an app. We have an app on the App Store. It's called 6. So you can see it's called 6 by Immersion Neuroscience. I am with him as what's called 6FX. It's a specialized version of his app that includes all of my learning stuff, which you're being told about right now. But you should download that. It's free and it's great. And if you have a wearable device, you can start using that right now. What that'll do is give you a good baseline of chemical situation. That helps you to manage your day-to-day scenarios and situations so that your chemicals are in a good state. Then you do my purposeful induction on top of that. But that thing is going to show you through the Apple Watch or the Oura Ring or whatever wearable device that integrates with all of them you have. That's going to show you what's going on in terms of cold hard data, published data. And the top, Paul Zach is published in all the top journals, as are my other associates there. Health Real app is Mr. Femi Ayan Badejo, formerly of the Baltimore Ravens, Super Bowl champion. He retired from football and has made this app. He is a specialist in human performance. And again, it gives you that solid baseline. It's about things like nutrition and hydration and sleep and basic things that I'm not teaching. There's plenty of other ways to do that. And Health Real is a good way to get that baseline solid. So then when you start to do a purposefully induced trigger reflex for your neuroplasticity, it matters a lot more. And then there's one more thing I want to show you, the panorama induction. This is kind of my signature move here. I'm going to show you guys this in this video. Let's say you have your phone and you open up your standard cell phone to the panorama function. Panorama like this. You're all familiar with this, where you swing the camera and you have to keep that little white arrow on that yellow line. Recognize that as minute error correction. Take about 4 panoramas where you go all the way across. And then actually, I don't know if you know this, but you can reverse it like that and then do 3 or 4 in the opposite direction. Each time making the picture a little bit better. and go all the way across until it stops. Now, next and finally, I'm going to end on this because this is my big thing. Take it and turn it upways like this. So your panorama is normally here, turn it up. And in this case, I'm going to ask you to do the same thing, panorama, start it, and now you're doing it all the way back. And your head is going back, and you keep going as far as you can safely go. And ultimately, if you turn the phone enough, you'll have a picture that shows the front and the back horizon. You'll have very carefully moved your head back safely. You'll be watching that arrow. It's very hard to keep it on when you're going back, back, and back. And you will have your brain triggered up with a whole bunch of magic memory mix. And you'll be able to learn anything faster and smarter instead of slower and dumber. Thank you very much. I hope this was helpful. Have a good day.